Okay, here's a story problem that uses the law of sines. We want to measure the height of a tree. Here's our tree. Oops, get a pen. Here's our tree. It's a nice bushy tree. If we go 100 feet away from it, we can look up at it. The angle from the ground to the top of the tree is 33 degrees. So from the ground. So you know what? We're going to assume that the person lies down on the ground or is standing in a hole so that his eye level is actually the ground. Okay? So that just makes it easier for us to visualize what's going on here and not have to account for the height of the person. So the 33 degrees is the angle between looking up at the top of the tree and the ground, which is not necessarily horizontal because the tree is at an 83-degree angle with the ground, not a 90-degree angle. So either the ground is not level or the tree is growing on a slant. Either way, that's an 83-degree angle. This is our 100 feet. We want to find out how tall the tree is. Well, first off, we know triangles add up to 180. We've got 83 here and 33 there, so that's what, 116. 116. Take that away from 180, and we've got 64 degrees left to put in this remaining angle. Then the law of sine says that the sine of 64 degrees divided by 100 should be the same as the sine of 33 degrees divided by x. It's also the sine equal to the sine of 83 divided by whatever this is over here, but we don't care what that is. So the law of sine says these two ratios have to be the same. It's the angle and the side across from it. So what that means is we can make this a nice simple fish problem. Sine of 33 times 100 divided by sine of 64. And we just go over to our calculator and we type that all in. So let's see, we've got the sine of 33, making sure to close the parentheses to say I'm done with that sine, times 100 divided by the sine of 64. And we find out how tall our tree is. Our tree is 60.6. 60.6. Since this measurement here was 100 feet, this is 60.6 feet. If you think about the law of sines, the sine of one angle divided by the length of the side across from it is equal to the sine of another angle divided by the length of the side across from it. In a triangle, we are calling capital A, B, and C the names of the angles, and lowercase a, B, and C the names of the sides, making sure that we put the letters across from each other. If we are going to be able to solve this using fish problem, proportion, cross multiplication, however you choose to solve these, it's required that we know both the top and the bottom of one of the three fractions. In this previous example, we had the sine of 64 and we had the side across from it. Sine of 64 and 100, those were one of those three fractions, and we knew both of those numbers. One of the other fractions had a variable in it, x, and that's okay because then we were able to use the fish. But imagine that we have a situation like we know that this is 8 units, and this is 7 units, and this is a 82-degree angle. Then we would have something like the sine of 82 over A equals the sine of B over 8, which is equal to the sine of C over 7. I can't make this a fish because every single fraction, every single one of these ratios is missing one piece of information. So we can't do it in that case. What that means is we have to think about when we are allowed to use the law of sines. We are allowed to use the law of sines if we have both the top and bottom of each set of fraction. So if you think about what that means I have to know an angle and the side across from it. One of the angles and one of the sides across from it. Well, and then the other piece of information that we will need is something in one of the other fractions. So say we know this side here. Then I would be able to make one fraction out of these two, another fraction out of these two, which would let me find out that angle. And once I know that angle, then I know this angle. And now that I know that angle, I can make a fraction out of this angle and that side and find the remaining side. And so we are able to find everything out about this triangle. We're going to call this an angle, a side-side angle triangle, because we know a side, then we know another side, then we know an angle. And we can use the law of sines on this. Say we had our angle and the side across from it, and another angle. Well, if we know two angles, we really do know the third. So we know all three angles. Then I've got a fraction that I can make out of these two, a fraction I can make out of those two, and because I know one of them, I can find out the other. And because I know those two angles, I know the third angle, which means I can find the third side. And so we are able to use the law of sines here. Because I know an angle, and then another angle, and then a side, we'll call this an angle-angle-side triangle. And we are allowed to use the law of sines here, LOS, law of sines. We have to know an angle, we have to know the side across from it. What if we had, whoops, I'm sorry, let me back up here. What if we had a triangle like this one, where I know an angle, and I know another angle, and I know a side? I don't have an angle and a side across from it. But I really do, even though it doesn't look like it, because since we know two angles, we know the third one too, because they have to add up to 180. And so now there's an angle and a side across from it, which means I am able to use the law of sines. So remember, we started with this angle, that side, this angle. We would call this an angle-side-angle triangle, and we are allowed to use the law of sines on it. One of these cases, side-side angle, angle-angle-side, angle-side-angle, one of these cases is a real problem for us. It's side-side angle. We don't really love it when we run into side-side angle triangles, because it's going to turn out that there's two possibilities for what the answer can be when we do a side-side angle triangle. The reason for that comes back to the fact that sine is not a one-to-one function once we allow our angle to become obtuse, which we are for the law of sines. So I want us to be thinking about, and we'll see in the next video tomorrow, why side-side angle triangles can really be a problem with the law of sines, because there's not just one way to get the final answer.